Hi everyone, it's Mrs. Sommer here to talk about lesson 505, the ideal gas law. In this lesson, you will be able to define an ideal gas and find an unknown using the ideal gas formula. If you recall, P is equal to pressure, and we are measured in standard atmospheres, which is ATM. Volume is measured, V is volume, and it's measured in liters, L. T is temperature, and it's measured in Kelvin. Now recall that there are many other units of pressure, volume, and temperature that you could use, but in this class, we're going to stick to the basics and use atmospheres, liters, and Kelvin. So what is an ideal gas? An ideal gas is a hypothetical gas whose molecules occupy negligible space, which means very little space, and have no interactions, and which consequently obey the gas laws exactly. So what it's saying is that it has so the molecules in between each other. So let's say we had a water gas molecule, and we have O, and then we have H and H. What it's saying is that there are no, and then we have another water molecule. We have H and H. There's no interaction between these in the gas phase. They're not interacting, and so there's no attraction. We're assuming there's no attraction between the individual molecules in a gas. So what is the ideal gas law? The ideal gas law is a single equation that relates the pressure, volume, temperature, and number of moles of an ideal gas. This is the ideal gas law. Write this down in your notes. PV equals nRT. N is your number of N is moles of substance. It's the quantity of substance. In Unit 6, we will be exploring the concept of moles in a lot more detail. But for now, just know that it's the quantity of how much you have, how much of the gas you have. R is the ideal gas constant. It never ever changes. It might change because you're using different units, but it never changes what it means. And in our class, we're going to be using the ideal gas constant as 0.08206 liters times atmospheres divided by moles Kelvin. So a couple rearrangements based on what you're trying to solve for. If you're trying to solve for P, the equation looks like this. P equals nRT divided by volume. Because all you did was rearrange it. To solve for P, you just divided everything by V to get P by itself. If you wanted to solve for volume is equal to nRT divided by P because you want to get V by itself. If we were solving for T would equal PV divided by N times R because temperature, we want to get temperature by itself, so we have to divide by N and R to get the T by itself. And N is, if you're trying to find the number of moles, it's PV divided by RT. You're never going to try to find R because R is a given. It will always be given to you. So to set up the problems, read the problem carefully and collect the values for each variable. So a table is very helpful to set up your problems. So those of you who really struggle with setting up word problems, use a table, okay? And then identify which variable you're solving for. So are you solving for P? Are you solving for V? Are you solving for N? Or are you solving for T? And then pick the correct equation to fill in. So you will be given on the test this equation, PV equals nRT. You won't be given those other forms on the previous slide. And you're going to have to solve for whatever variable you're looking for. So if it's V, you're going to have to remember to divide by P. Okay? Then fill in the data points that you have and then run the calculations. Here's an example. How many moles of a gas does it take to occupy 120 liters at a pressure of 2.3 atmospheres and a temperature of 340 K? So read the problem carefully and collect the values for each variable. Identify which variable you are solving for. And then pick the correct equation to fill in, and then run the calculations. So in this example, it says, how many moles of a gas does it take to occupy 120 liters at a pressure of 2.3 atmospheres and a temperature of 340 K? So what is step 1? We need to fill in our table. Your pressure given was 2.3 atm. Your pressure given is right here. Oops. Then what is the volume given? 120 liters. Okay. And this is what it's asking you to find. How many moles? So N, we don't know yet. So N stays as N because we don't know what it is. R is a constant, so it never changes. And the temperature we were given is 300, oops, I want to do a different color, 340 K. So now that we have that, we need to rearrange to solve for the variable that we're looking for. We're looking for N here. So when we rearrange our equation, we get N is equal to PV divided by R times T. Then we just start filling in our variables. So my N, oops, I want to cover that one back up a little bit. My N is equal to 2.3, my pressure, times 120 liters, divided by 0.08206 liters times atmosphere, divided by mole Kelvin, times 340. What that looks like over here, and I can zoom in, is that when you go to cancel your units, you have unit liters on here, you have atmospheres here, you have Kelvin and Kelvin here, and so they cancel, and all you're left with is the moles, which is the unit for N. Okay, when you go to put this in a calculator, because I don't expect any of you to do this by hand, any of this math by hand, you use a calculator, okay? You would write it as, if you're putting the whole thing into your calculator as one big giant thing, you need to follow some rules for formatting the calculator. So in a calculator, calc, what you want to do is put as parenthesis 2.3 times 120 divided by parentheses 0.08206 times 304. Oops, let me get a better color. 340. Okay? You put the parentheses. If you don't put your parentheses where they matter, the calculator will not give you the right value. Okay? If you're doing it separate, a lot of times what I do is I do this math, and then I divide the two numbers. So when I do that, my N is actually equal to 9.89 moles. And so here's my solution. So 9.89 moles occupy 120 liters at 2.3 atmospheres and a temperature of 340 K. Here's one that I want you to try as well. If I have 50-liter container that holds 45 moles of gas at a temperature of 473 K, what is the pressure inside the container? So remember to read the problem and collect your values in the table. Identify which variable you're solving for. Rearrange your equation or pick the correct equation to fill in, and then run the calculations. Okay, going to solve this equation, this problem, it says I have 50-liter container that holds 45 moles of gas at a temperature of 473 K. What is the pressure inside the container? So, P, oops, I don't want to put that down there yet. P, we would just write P because we're trying to find the pressure. It says, what is the pressure? That's the question we're trying to find. Then, I have 50 liter that holds 45 moles at this temperature. So my volume is 50 liters. My N is 45 moles. And my T is 473 K. Then I'm going to rearrange my equation, and I get P is equal to N times RT over V. And then I'm going to plug in my values. So P is equal to 45 mole times R, which is 0.08206, times 473, all divided by 50. When I do that, I get P is equal, my moles cancel, my liters cancel, my kelvins cancel, and I'm left with my unit of ATM. And when I perform those calculations, I get my answer to be 34.83 ATM. Okay? So, and that's where this number comes in. Remember, if you're using it in a calculator, you would do, so calc, you would do parentheses 45 times 0.08206 times 473, then all of that divided by 50. Okay? You have to put the top in parentheses and then divide by 50. Otherwise, your calculator will give you an incorrect answer because you inputted it incorrectly.